Section 3.3, using several transformations. Objective: to solve equations by using more than one transformation. Yeehaw! Says the math cowboy. Before we were using just addition and subtraction, then we're using just multiplication or just one of those. Now we're going to use more than one transformation, and this is going to be exciting. I'm excited. I'm excited about this because this is when we really start to get into some, real fun algebra. So just as we can do things on both sides of the equation as we were doing, or as you were doing, or as you do, we can undo things. For example, if I start out with x here, and I multiply, let's see, I'm going to multiply by 3, and I end up with 3x. Then I subtract 8, and I end up with 3x minus 8. Well, suppose I wanted to start off with 3x minus 8 and reverse that. Well, I want to undo this negative 8. See, I have 3 times x, and I have minus 8. So to undo that minus 8, I can just add 8. If I add 8, it undoes that. I end up with just 3x. And let's see, to get from x to 3x, I multiply by 3. To undo that, I'm going to do the opposite. I'm going to divide by 3. Ooh, neato. And I end up with x, right? So I got back to it. So we're going to be undoing things to solve equations. This is exciting. Loving it. Loving it, man. Loving it. So algebraically, how do we say that? Well, here it is, defined algebraically for, real numbers A, B, and C. Well, here A and B. A plus B, if you have A plus B, or A and B, and then you subtract B, you're back to A. So you can just say, basically, subtraction undoes adding. For instance, 5 plus 9 is what? 14, right? And 14 minus 9, I'm back at 5. Here, A plus B, A minus B plus B, you're back to A. So if you subtract B from something, then add that B again, and then add B, you're back at A where you started at. For instance, ready? 5 minus 8, right? What is 5 minus 8? We're at negative 3, right? And if I get started, and now I'm at, this number here is negative 3, plus 8, where am I? Back at 5. Again, adding undoes subtraction, just like subtraction undoes adding. Now here we have multiplication division. A times B, if you have A, multiply by B, and then divide by B, you're back at A. For instance, 5 times 7, we know that's 35. And we divide by 7, where are we? Back at 5. Division undoes multiplication. Just like over here, we have multiplication undoing division. For instance, 63 divided by 7. What is 63 divided by 7? We know that's 9, right? So this number in here now is 9. If I take that 9 and multiply by 7, I get back to 63, right? Cool. So let's undo an equation for fun. Let's undo it. Sometimes I like to call this peel the onion. I imagine like an onion, like what's closest to the variable. I'm trying to peel it up so the variable is all alone. So sometimes I like kind of picture an onion, right? And the variable is kind of in the onion, and then the closest layer to it would be the 6. I mean, this is kind of silly, but anyway, so I start on the outside, I start far away and start undoing things, unraveling this equation, and so I'm going to start by removing that negative 8, or undoing that subtract 8. I'm going to undo a subtract 8 by adding 8. Now remember, bingo, equality. This is balanced. Both sides are equal. So whatever I do on one side, I must remain the equality by doing it on the other side. I have my 6m's equal to 48. All right, now let's see. I want to undo this. I have m times 6. To undo the 6, I'm going to divide by 6. And 6 undone is just m. I undone it, or undid it. 48 divided by 6 is 8. I've solved it. Let's just double check. 6 times 8 is 48, minus 8 is 40. Oh man, someone's calling me. Hey! Stop calling me! Hold on. There we go, I just hung up on him. Alright, so, nice. Let's undo another equation. Woo! Look at this one, it's got a fraction in it. And I know what happens when you see fractions. You get excited. You say, I can't wait. I love it. I can't wait to solve this problem with a fraction and show everybody how fraction-tabulous I am. Well, let's undo this. Remember, we're going to peel the onion. I want to undo, this is 1/2 times y minus 12, right? So the last thing that was done to this was a minus 12. So let's undo this minus 12 by adding 12 to both sides. Now remember again, right? We have to remember that this is like a scale, right? And it's balanced. It's totally even. If I just add 12 to this side, it's going to go. It's going to just go. Right? I need to maintain the equality. It's equal, man. It's equal. We've got to keep that equality. So here we go. Adding 12 to both sides. A negative 12 and a positive 12 cancel each other out. I end up with just 1/2 y. Well, you can think of the plus 12 undoing the minus 12. And over here, negative 2 and positive 12 is 10. I'm almost done. Now I can divide by both sides. I have 1/2 times y. Now I can divide both sides by 1/2. Now there's a couple ways people look at this. I'm going to show you both ways over here. And some people. And either way, you're going to end up with the same result. Some people will walk out. You can do this. You can just say, hey, I'm going to divide both sides by 1/2, right? Which is fine. 1/2 divided by 1/2 is 1. 10 divided by 1/2 is the same thing as 10 times 2, right? Dividing by 1/2. The same thing as multiplying by its reciprocal, 2 over 1, right? Or some people will just write it right out, 10 over 1 times 2 over 1, and they get 20. Another way you can do this, instead of writing that dividing by 1/2, you know dividing by 1/2 is the same thing as multiplying by the reciprocal. So you can just multiply both sides by its reciprocal. The reciprocal of 1 over 2 is 2 over 1, right? And you know these guys are going to end up being 1. 10 times 2 is 20. So either way, double check. Let's make sure this is 20. What's half of 20? Half of 20 is 10. What's 10 minus 12? 10 minus 12 is negative 2. Sweet. We're almost done, people. All right, here we have another tricky one. Whoa. Let's talk about the onion again here. We've got an onion, don't we? And here's our x, and then the minus 15, and like the furthest kind of thing away, we can see like the last thing that was done to that x was divide by 3. So how can I undo this divide by 3? Well, simple. Multiply by 3. Both sides. I'm going to multiply both sides by 3, and what happens? We can cancel these out, right? I mean, because 3/3 is 1. Or we can switch this around, so we can rewrite this as 3 over 3 times x minus 15 over 1, because these guys switch around, right? Whatever. Cancel these things, right? X minus 15 equals 12. Now what I want to do, undo this minus 15 by adding 15 to both sides of the scale. And what do I end up with? X equals 12 and 15, 27. Is this true? Is x equal to 27? Let me double check. What's 27 minus 15? 27 minus 15 is 12. So 12 divided by 3, 4. Bingo. I did it right. I double checked it. All right? So let's make an equation here. So, you know, if you were the textbook writer, you're going to want to make an equation and try to trick these people up, trick the students up, make them think to do these things. So let's do, you know, what the equation maker would do, the text writer. Let's multiply both sides by 12. We can do that. And, you know, this is going to be our answer. So I get 12x equals 8 times 12 is 96. Let's add negative 30. So 12x minus 30. And 96 minus 30 is 66. Let's rearrange. All right, so let's write this as, let's see, 4x minus 30 plus 8x equals 66. See that? 4x and 8x is still 12x. I'm just trying to make this tricky, you know. And let's divide both sides by 2. So I have to divide this whole thing by 2 and this whole thing by 2. And when I divide a side by 2, remember I have to divide every bit of it by 2, right? This is all divided by 2, right? You know what I'm saying? Just like when you multiply everything by 2. Well, when I'm dividing, I divide it all. So I get 2x minus 15 plus 4x equals 33. There you go. Put that in your book and see if your students can solve that. Is x still equal to 8? Yes, it's still equal to 8. I did the same thing to both sides. I maintained the equality. I have 16 minus 15 plus 4 times 8, which is 32. Equals 33. Let's double check. 16 minus 15 is 1, and 32 is 33. So I just made an equation from starting from scratch. Now I'm going to bomb through this next one as fast as I can because I only have like 30 seconds left. Let's see. Ready? 4k plus 8 minus 3 plus k. All 1/5. 4k and k is 5k. Plus 5. 1/5 of 5k is k plus 1 equals 4. K must equal 3. All right, that's as fast as I could go. I'll talk to you guys later. I think that's right. Let's double check. 3 and 2 is 520. I don't have time. Time's running out. Have a nice day.